Hi lads, so today we're going to move on to this chapter here, Circles 2. So the SolidWorks and sketching chapters, we'll come back to them. You've done a lot of sketching anyway throughout the course. We've been doing little bits of posters and little tasks where it involves sketching, including the one that I gave you last where you had to sketch your this over here. This sketching task here in orthographic projection that we did last. So you would have done a bit of sketching today, so we'll set aside them two chapters and refer back to them throughout the next few. But today we're going to move on to the second part of circles. So we have the fundamentals, really. We have the basics done, where we've learned what a circle is. So it says here in chapter 7 we learned that a circle is a curved plane figure. And I also said to you that it was the path of one point, the path of a point that travels around, the path of a point that travels around a fixed point at a fixed distance. So if that's the point in the middle, a circle is the path of that point that travels around it, but travels around that fixed point, so that fixed point doesn't move, travels around that fixed point at a fixed distance, so it doesn't, the distance from the center to the outside doesn't change, so that's the path, so it's moving. Alright, it says here, circle is a curved plane figure, which is correct also. Alright, and we also learned that a tangent is a straight line that touches the circumference of the circle at one point only. So we did that, you did the locator thing that's in Google, this kind of that question we did with the circle in it, and we also did these magnifying glass. So we did two tangents there. Now, so we're going to page 152. So what we're doing here is we are going to draw a tangent between two circles. Alright, so that's what we want to do today. So if you want to start lining the sheets, tangents to the circles, and our first keyword is tangent. Okay, so it says here in chapter 7 we learned how to draw tangents from a point to a circle. We will now learn how to draw tangents between two circles. So there are two types of tangents in circles. There's an external tangent and an internal tangent. So when we're talking about tangents to circles, and there's loads of examples here, you may not have thought about it before, but you've seen loads and loads and loads of tangents between two circles. But there are two types. There's an external tangent and there's an internal tangent. Alright, and we'll have a look at both. So here we have a tangent that's external. So when you're talking about an external tangent, a tangent is external when two or more circles on the same side of the tangent. So when there are two or more circles on the same side of a tangent. So so you can see here we have a circle, and the line is on the same side of the two of them. Alright? The external tangent touches each circle at a single point called a point of contact. So the point of contact is where it touches the circle, where the line touches the circle is called a point of contact. A normal is a straight line that is perpendicular to the tangent. So you can see here, that line there, it's perpendicular to the tangent. It's called a normal. Okay? The point of contact is the intersection point between the normal and the tangent. Right, so we have a lot in there, and we'll stick it into a few words. So we have external. So external. So this is an external tangent. Okay. We have point of contact, and I'm going to show you the abbreviation for that. Point of contact, and the abbreviation you put in drawing, the shortened version you put in your drawing, put in brackets here if you can fit it in, is POC. Maybe a little bit smaller so I could fit it in. There we are. There. Is that right? So POC is your point of contact. So when you're labeling it, you can put it in as POC. So they've given some examples of an external tangent. So it's a line joining two circles that touches at one point only. And here are a few examples. So look, you can see here, you have the little pulley here with the rope in between. So you can see there's a circle here, and the tangent is going like that. Now, a few more difficult ones to spot down here. So if you look in your book, there's a game controller. What sort of tangents are going on here? So a game controller and a bike. So where would the tangent be in a bike? So there's two wheels there. I don't see any line joining them. Well, the line would be the ground. So the ground is joining. So the ground is joining this wheel to this wheel. There's a line going on. If you look straight in along the ground, there's a line joining two of them there along the ground. And the point of contact will be where the wheel is touching the ground here and where the wheel is touching the ground there. And if we want to go into detail, we draw a right angle from the middle of the spokes at right angles to the ground. That will give us the normal. Same here, in the middle of the spokes, the center of the circle, right angles to the ground, straight down will give us our normal. Alright? Here in our in our PlayStation 4 controller, so a little bit more harder to spot there, but you can see there's a circle here that isn't all there, but you can see that's an arc of a circle, so that's going to be a full circle. And you can see a line, and there's a circle here where the buttons are contained. And you can see there's a line on the outside here joining the two circles. See that there? See that there on the outside. There's probably a few more. See if you can spot a few more, but they're the two external tangents that we're talking about. Alright? So that's what an external tangent is. An internal tangent. So a tangent is internal when there are two circles on opposite sides. So the last time we had same side. So we'll put that in for should put brackets after. So external is same side, right? Same side. And internal is opposite sides. Opposite sides. Just get that in. So opposite sides. So that's the same side, that's opposite sides. Okay. So an internal tangent is when there are two circles on opposite sides of the tangent. The internal tangent touches each circle at a single point called a point of contact. That remains the same. And the definition of a normal is still the same. A normal is a straight line, it says in brackets radius, that is perpendicular to the tangent. So perpendicular to the tangent, the point of contact is the intersection point between the normal and the tangent. So look, it's a lot taken there. So we have two circles, and instead of the tangent being external, it is internal. It is going to opposite sides. So this side of the line is on this side of the circle, whereas this side of the line is on this side of the circle. So they're opposite sides. So it's an internal tangent. You can see an example here inside an engine. With the fan belt or something inside an engine. So you have a belt going around there, and you can see if the belt was going from there around the outside, that would be an external tangent, but it's going internal here. We have another example here. So now these images, can you identify the internal tangent? So the tape dispenser. So can you see the internal tangent in there? You can see, look, the tape. If the tape was going around the outside of the tape and the tape was flowing down to the outside of this little rolly wheel here, then that would be external, but it's going inside. So it's an internal tangent. So big thing here, lads, is even spotting them. Like spotting, geez, I know the difference between internal and external because there's two different methods to do it. So the big thing to get out of this is, can you spot an internal and an external tangent? Can you identify the difference between the both of them? So here we have the same, look. The pulley wheel going up, or the weight experiment apparatus. You might have done this in science. So you can see the string is coming along, and if it was going from there to the outside of the circle, what would that be? Be external, but it's not. It's going from the inside of this circle to the outside of that circle. So it's an internal tangent. Alright? Now you can do that activity there on your own and maybe pop it in the comments. There's 1, 2, 3, 4, 5, 6, 7, 7 different tangents there. I just want you to put in the first, if you want, put in 2 numbers, put external 6, 5, 4, whatever it is, external 6, 5, 4, internal 4, 5, 7, whatever it is. Just put in the name of the tangent and the number of them, the name of the tangent. So it says the various tangents are labelled with letters in this diagram. In pairs, identify the external tangents and the internal tangents. Alright? So you don't have to put in for each particular letter, just say how many of them are there. Okay? Alright, lads, so we'll move on to actually drawing an external and internal tangent. We'll start with the external one. So I'm going to stick in a few more just keywords just from that book. So see, can you remember any that we need to stick in that came up there a few times? What sort of stuff came up? What did we miss out of that? So we have a tangent, we have external, we have opposite sides, same sides. We're missing the normal, so that was the line at right angles to the tangent at the point of contact. So we'll draw that in a minute, but you can see what okay, so we'll start with this first question here, but you can follow my measurements here if you want. So we have 20, 26, 46, 4, 6 down. So if we come down 110, down 110, draw a line straight across there like that, and I'll come in 60. Alright, I'll come in 60, and then I will go up 66. So I'm getting all this from the book. If you want to, if you find it easier to look at it, that's fine. So down 110 and 60, up 66, and then over 60. So we do a few measurements there and we'll see how much you're listening. Right? Down 110 in 60, up 66 in 60. So we have 2 points there. So I'm just going to mark them in. There's a point there and there's a point there. Right? And they're the center of our 2 circles. So I want you to draw there. I want you to draw 2 circles. One circle is going to be 40 millimeters. And there's that. 40 millimeters. Here's my 40 millimeter circle. So you're doing all this now, lads. And then I'm going to do another circle up here, which is going to be 20 millimeters. So it's 20 and point my compass at the point. Okay, there we go. So there's the 2 circles. So what we're going to do is we're going to draw a tangent between the 2 of them, and it's going to be an external tangent. Okay, so it's going to be an external tangent. So what is the method for doing it? So I've news for you first of all anyway. You can't draw a tangent between 2 circles. That's the first big shock there, right? So you actually can't draw a circle. You can't draw a tangent between 2 circles. You have to actually trick the 2 circles into giving you the tangent, right? And what you do to trick them into it is you reduce one of them, you make one of them a point. Okay, so in both cases, you have to make one of them a point. So for an external and internal, you have to make one of them a point. So we're going to just do external today. So we're just concentrating external. So you have to make one of them a point, but you can't just make one of them a point and say, well, that's it done. You can't just do that. What you have to do is, if you're going to make one of them a point, you have to do something else with the other one. Alright, you have to compensate for it. So we've learned how to make a tangent between a point and a circle. So let's use that method. So we'll do that. Right, so what you do is you make the smaller one a point. Okay, so I have a big circle and a small circle. What I'm going to do is I'm going to reduce that down. So it's not a circle anymore, it's a point. Okay, but if I'm going to reduce that down, I have to take that radius from the other one. So if I'm going to reduce that to a point, I also have to reduce this. For an external tangent, I also have to reduce this. Okay, so what I do is I'll take the radius of this circle here, right, and that's the radius of the bigger circle, and I'm going to take the radius of the small circle away from it. So that was the radius of the big circle, and I've taken that much off it. Okay, and then I'm going to draw that as a new circle with the reduced radius. Alright, so I've taken 20 off that. It is the radius as 20. So taking the radius off that, I've made that a smaller circle, and that got reduced down to a point. So now I've got a point and I've got a circle. Okay, so if you remember how to do this, you may or may not. If you remember how to do this, so now we've a completely new problem. We've got a point and a circle, and we can work from that. Alright, so if I want to get, if anyone remembers, if I want to get a tangent between a point and a circle, so now we're just concentrating on these two bits here, right? To get a tangent between a point and a circle, I join the point to the center of the circle. I join the point to the center of the circle. Okay? And I bisect that line. So we're forgetting now about the H circles here. We have a point and a center of a circle, and I'm going to bisect that. Swing an arc, swing an arc. Don't change my compass. Swing an arc, swing an arc. And I'll get my bisector. So there's my bisector there. Stick that in our keywords, actually, we can see that now. So my bisector. So there's my bisector. That gives me the center of the circle. Or sorry, the center of that line. So the center of that line. Okay, there's the center of the line. And now I put the point of my compass on the center of that line, and I draw an arc from the center of that, the center of the line to the center of the circle. That's my new radius. I draw an arc there. Okay, now when I draw that arc where it cuts through the circle, it gives me a point here and a point here. So 2 points. Okay, so there's a point there, a point there. Now the two of them points, as we know, we've done it before, that is the point of contact between the point outside the circle and the circle. So there is my tangent. Okay, and there is a second tangent on the other side, like that. So if it was a point and a circle, that's what we need to do. But as you know, lads, we're not doing that today. What we're trying to do now is we're trying to find a tangent between two circles. Okay, so what we do, we're going to still use that. So I can tell you now that tangent there is going to be parallel to the tangent I need. That's why we drifted into it. So all I need to do is draw the normal to that tangent, which is going from the center of the circle out to the point of contact, go from the center of the circle, and we extend it out like that. We extend it past our point of contact onto the other circle, and now we have a point of contact POC for our new tangent. Okay, so we have a POC for our new tangent, and we also have this thing here. Let's get an arrow out of it, which is our normal. Just do that in green now. So we've got POC and we have our normal. Okay. So now I know that that line is going to hit it there, and so the tangent is going to go like that. It's going to be at 90 degrees to that. Well, if that normal is that direction for this line, for this circle, and the tangent is going to be 90 degrees to it, well, it has to be the same for the other circle. So I can take that line, and I can slide my set squares over. My set squares over, so I get parallel to that line, and it slides over there like that, and I'll draw the normal for the other one. So same here, normal, and the two of them are parallel, have to be, because if they're both at right angles to the tangent, then they're both parallel, because it's the same line, because they're right angles to the same line. Okay, so I have my normal, I extend that out, I have my two normals, so that means I also have my 2 points of contact. Alright, point of contact, point of contact. With my 2 points of contact, and I also have my tangent. So there's my tangent there. Okay, there's my tangent there. So I label that. So there's my tangent. Alright, I can do the same on the other side. If we wanted to get the tangent to go on the other side also, I'll do it again, just as a reminder. So we'll extend. So that would have been, if it was the point in the circle, that would have been the point of contact between the point and the circle. But as we know, we've tricked it into giving us the point of contact for the bigger circle. So we'll extend that out, the normal out until it hits there. There's a point of contact. We go parallel to that. Parallel to that. So there's my parallel line. Go through the center of the other circle. There we go. Gives us the point of contact. And then we've got the other tangent. So there's our tangents to the two. There's both tangents to the 2 circles there. Alright, now I want you to complete all that, lads. Exactly what I've done there. And I also want you to that. What one will I give you? I'll give you, if I give you question 1, look, that's fine. Question 1. Will you stick question 1, or sorry, question 2 on page 155 in here as well? So use the exact same method. Don't draw the circles that you need, and then think about what I said. Take the radius of one circle off the other one, reduce that down to a smaller circle, and reduce that down to a point, and work away from there. So I want you to do question 2 as well on page 55. Thanks.